So I first met Boris Magasanik at an ASM meeting when I had finished my graduate studies and I was looking for a postdoc. And it was the greatest break in my life to get that position, obviously. I had one other job offer at the time, which was to work for a grain milling company for $24,000 a year. And I think I made the right choice. So, of course, working with Boris was a great honor. And I worked at the same time as Aaron and Larry, and Peter was there at the same time. So at this stage in his career, Boris was already a phenomenal scientist, world-known, and well accomplished. And he really was not up on the technical details of what we were doing at the bench at the time, to be perfectly honest. And that was a great power to him. Boris did not get bogged down at sort of what he could do, because he could do anything. He had us. So he really thought at another level, and it was a great honor just to be near him for that. So he would come in the lab all the time, and Larry and I had the bench next to one another, and Boris would come in and lean against one bench or the other and say, you know, I was thinking about all the data last night, and here's a model for how I would think it would work. And this was like a daily occurrence. These phenomenal models. And I see Raphael is nodding in agreement. And they were just, the creativity and imagination was like, you were humbled. You felt like, where does this come from with this person? And one day, I'll never forget this particular day, Boris comes in the lab and he goes, I was thinking about all the data and I think I have a hypothesis, as always. And he was leaning against Greg Pale's bench at the time. And he said, the model of what is nitrogen regulation in E. coli. He said it. He just imagined it. Of course, he did not know the technical details of the covalent modifications. And in fact, Boris's mind, loving of symmetry, sort of guessed wrong in that small area. But basically, the model was dead on. He had every role. So. And I was sitting there listening to it, and I said, damn, that sounds right. And basically for the next 31 years, I've studied these systems. I love these systems, and I guess I can't put them down. And I've used them for other purposes, of course. But so that was sort of the great thrill of working with Boris. This amazing creativity, this amazing imagination. And it was sort of joyous, almost childlike. He had fun coming up with these models, these hypotheses. So, and that was, of course, damn thrilling. And of course, the other guys that worked with him, I'm sure they'll tell you the same thing. Okay, so now I'll talk about the scientific portion of my presentation, which I hope to conclude in about 2 or 3 minutes, and then I'll talk some more about Boris. So I've studied the single chain induction systems that control glutamine synthetase for 31 years. And we reconstituted the systems back in the last century. And I have a lot of mutants, and we've studied every property you can think of with the systems. And it's been a great joy now to sort of study the systems biology of these regulatory systems. And it's the kind of questions that really could not be addressed before. So one of the things I did recently is I identified a glutaminase from bacteria, different bacteria, with a very low Km. I searched the world for it, and as these things turn out, it was right in the next building over in a structural genomics lab. So with this glutaminase, I could set it against glutamine synthetase, and I could provide plenty of the reagents for the glutamine synthetase reaction, glutamate and ATP. And I could even provide a coupling system to regenerate ATP with enormous capacity, by the way. And I could add the signal transduction system. So now I have, in vitro, a metabolic homeostatic system. It will maintain its glutamine concentration. If I dump in more glutamine synthetase, it gets inactivated by adenylation. If I dump in more glutaminase, glutamine synthetase gets de-adenylated and activated to counteract the glutaminase. And the system will rock on hold the glutamine concentration for a long time until the coupling system dies. So we could ask a lot of system biology questions about what does it take to get homeostasis in vitro with a defined system. So anyway, just to cut it short, I'll just talk about one little part of it. The ATAs, the enzyme that modifies glutamine synthetase and demodifies it, is of course a so-called ambiguous enzyme. It does both activities. Both activities are tethered together, if you will. So it turns out that we could, of course, make mutants in those activities. So we have the individual monomeric enzymes, and we could squirt them in the system in all different proportions. And we found that the system is not robust to glutamine synthetase. The adenylation control system can only control it for so much. And then at a certain point, if you add glutamine synthetase, it's frankly not robust. It fails to hold the glutamine constant. And the point where it fails is determined by the AT and AR levels, the two activities. And we could vary that point by varying those two activities. And we could even make systems that were more robust than the natural system by varying those activities. So I talked to Boris about this. It was actually about a year ago, I think last summer. And I talked to Boris about it on the telephone, and I described to him how its failure was evolved. It's an evolved trait. Not only is it not robust, but it's designed to fail. That the glutamine homeostasis that we observe by looking at cells is an emergent property of many different systems all working together. And this system is obviously not responsible for that whole process. And Boris understood it and very drolly remarked, well, of course, you know, it evolved to work in cells. So I guess I'm not going to talk too much more about science. I have a few minutes left, I think. So I'd like to talk about some remembrances of Boris. Of course, he's very special and sort of had a big part in all of our lives. So I'll talk about a few little funny remembrances of Boris I had. So, you know, Boris gave many beautiful seminars. I think the best seminar I ever saw in my life was in the year 1983 in Farmington, Connecticut, where Boris talked at the University of Connecticut Health Science Center. I think it was maybe 200 people in a packed room, students in the aisles, and Boris sat on a stool and without aid of blackboard or anything, spoke for exactly an hour in utter clarity. No notes needed. And in fact, notes or images are restrictive to a person like Boris. They channel his thought. He'd rather not be channeled. So and that was a lesson of great propagating about it. So anyway, one time, now to continue the story, I met Boris, oddly enough, in ASM pre-screening room to check one's slides. This is about, I guess, 10 years after I worked with Boris. And I had always bugged Boris, you should use slides, you should use slides. And you're talking, I was like, I'm not going to use slides. So in the room, I see Boris Magasanik, and he goes, Alex, you won't believe what I have. I have slides. It turns out that Bill Crochet had made 2 slides for him, and they were these like 1.5-inch thick MIT slides, you know, with like window pane on both sides. They weigh about a quarter pound each. So you know how this story's going to end. So Boris gets up to give his talk, and he's going just fine, and he calls for the first slide, and it falls halfway down. And then he got a little messed up, and then he was okay. He just ignored it and started giving his normal seminar, and it was beautiful, of course, and very clear. But then they got the slide to fall, and he felt sort of obliged to go back and talk about the slide that messed up his seminar. He was really mad at me afterwards for that. I had nothing to do with that. So I guess I'll just say one more funny story about Boris. Of course, Boris is very dear to us. I deeply treasure the time I had with him. But I want to tell you one more story about Boris, and this time you have to wait for the punchline, because this one does have a delayed punchline. So when I was working sort of at one point in the work, and Larry was working at the next bench also, and we were making a lot of plasmids. In fact, Larry had shown that the upstream sites to which NO1-phosphate bound upstream of the glutamate promoter functioned as an enhancer in cells. And then later, Larry and Boris and I together had shown that those very same sites in the in vitro transcription system worked as an enhancer. In fact, on linear DNA, they could work from downstream of the promoter to activate transcription. So in the course of that, this is, of course, before PCR. Of course, we're, doing the technology of the time. So we were making a lot of plasmids, a huge amount of plasmids, because you had to sort of make 2 or 3 plasmids sometimes to get the one you wanted, because you sort of didn't have a good way to manipulate sites back in the day. So we were doing that, and Boris comes charging into the lab one afternoon, and he goes over to Larry's bench, actually not my bench, and he says, fellas, I know of a way we could speed everything up. Larry says, yeah, okay, what's that, Boris? And then Boris starts to, and I'm not kidding here, he's inventing molecular biology. He invented the mini prep in front of our eyes and rapid cloning methods. He was like, instead of doing plasmid preps, we should just do a small preparation from like a mill of bacteria. And he started to describe the Marmor prep, which actually is an ancient mini prep method that actually does work actually. And he's describing this. He says, we could do a miniature high salt precipitation method and get a little tiny bit of DNA and just run a gel and do the next step and not have to make a plasmid prep. And Larry is sitting there, I'll never forget this, and he's dumbfounded. He's looking at Boris and he goes, I know, Boris, they're called mini preps. This is how we do it. And Boris was, now wait, the punchline's still to come. But Boris was amazed that this whole technology existed. Sort of, he wasn't aware of how we were doing it. And he was also a little embarrassed because, we know Boris, right? So that sort of was a little embarrassing for him. So he said, where is the book with this mini prep? So at that time, Maniatis was one volume, so I gave him my copy of Maniatis. By the way, I still have that copy. It's still over my bench, and I still work at the bench with that book. Anyway, so I handed him my copy of Maniatis, and it was a Friday. He took it home for the weekend. So anyway, and then he gave it back to me on Monday. So now, here comes the punchline of the story. About 2 weeks later, I'm doing a series of experiments. And I'm using a sort of a restriction protection assay as a monitor of whether I have transcription complexes on a plasmid. And in fact, in those days, I could actually even form the transcription complexes on a plasmid and put it through a little gel filtration column right on my benchtop and have the DNA with transcription complexes on it. And then I would cut with the enzyme to see the fraction of protection to get an idea of what proportion of my complexes had, of my plasmids had transcription complexes. So it just so happened that the enzyme was Hindi3, that was the site that was protected. And so on my bench, I'm telling Boris about this assay, and I want to do this assay. And he made this amazing, very un-Magasanik comment. He goes to me, well, Hindi3 is a good choice of enzyme to use for that because of its high salt tolerance. You can just add it to your reaction mixtures. He wanted me to know he read Maniatis. And not only did he read Maniatis, but he added, as in everything he read, committed to memory. Anyway, those are my memories of Boris. Some of them, anyway. Of course, I could go on for many more, but others that want to speak. So, again, working with Boris was sort of one of the great pleasures, obviously. It was thrilling to go to work every day and just to sit next to him and have him talk to you, actually. It was a great honor. And so that was